This is the Math 2 lesson summary video for the lesson entitled Lining Up Quadratics. In Lining Up Quadratics, which is Lesson 8 of Unit 4, the purpose of this lesson is to use our knowledge from factoring in the previous lessons a quadratic function and graph that same function. We discover in this lesson that the x-intercepts, y-intercepts, and the vertical stretch of the parabola are visible in the equation. We discuss that quadratic functions are products of two linear factors. In Lesson 8, Lining Up Quadratics, we are asked to graph each function below in 1 through 4 and find the vertex, the y-intercept, and the x-intercepts. We are then asked to be sure to properly write the intercepts as points. So if we take a look at number 1, we can see that this equation is definitely in what we would call factored form, and we've been working in factored form for the previous several lessons in this unit. Throughout this lesson, we did use our graphing calculator to see if we notice any relationship between the factors and the x-intercepts, the y-intercepts, or the vertex. So the first thing we're going to do is go to our y equals in our graphing calculator, and we're going to make sure to type in that function in our y equals as the quantity x minus 1 times the quantity x plus 3. Keep in mind that this is the product of two linear factors. If I hit graph, we can see that this parabola faces up, and we can also see that it looks like our x-intercepts are -3 and +1. Keep in mind that our factors were x minus 1 times x plus 3. So we are asked to take a look and see if we can figure out how to find the x-intercepts based on our factors. Well, if we take each of our factors and set them equal to 0 and solve for the x value, we will be able to always get what our x-intercepts are for the parabola. So on this example, example 1, our x-intercepts are -3, 0 and 1, 0. So I'm going to draw my coordinate axes so we can graph these. This doesn't want to work with me today. So let's see here. So there's my y-axis. And my x-axis. Let's move it up just a little bit because we're going to have a y value. It's a little bit large. So here's x and y, and I'm going to use a different color to 1, 2, 3. That's -3. That's 1, 0. The next thing we're asked here is to find our line of symmetry. So if you recall from Math 1, our line of symmetry is the line that will be symmetric on our parabola, which means we can cut our parabola right down the line of symmetry, and both of our x-intercepts should line up. So if we can find the middle between -3 and 1, we should be able to find the line of symmetry. And that would indeed be at the line x equals -1. So the next step is to figure out our vertex. So to figure out our vertex, we discussed that you can plug in your x value for your line of symmetry. So in this case, it was x equals -1. And we're going to plug it back into our original equation that was in factored form. So when I simplify that, I'll get -1 minus 1, -2. -1 plus 3 is 2. Therefore, my y value would be -4. So I now know that my line of symmetry, or my vertex, my apologies, is -1, -4. So we can plot that. Let's go to -1, -4, 1, 2, 3, and 4, and my vertex should be right there. And the last thing that we discussed is how to find the y-intercept. Keep in mind whenever you cross the y-axis, your x value is always 0. So to find the x the y-intercept, we can plug 0 in wherever we see x in the equation, and this will always work for us to find the y-intercept. So -1 times 3, that means my y-intercept should cross at -3. So 0, -3 should be my y-intercept, -1, -2, -3. And then I can connect my points to make my parabola. So keep in mind here something that we want to talk about is how to also find a vertical stretch, which we're going to see in the next example. But what we do is we go from the vertex and we're trying to figure out what our vertical stretch would be. And if you recall from a previous lesson, remember that we go over 1 and up to A and over 2 up 4A. So to find our vertical stretch, we would go over 1 and up 2 times A. So let's apply that on the next example here, which does have a vertical stretch. So let's use the same information that we did from number 1 to do number 2. Now recall that from the factors, we should be able to find our x-intercepts by setting our factors equal to 0 and solving. 2 doesn't equal 0, so we don't have to worry about that. But we do have to set x minus 2 equal to 0 and x minus 6 equal to 0, solve for x, and these would be our x-intercepts. So x is 2 and x is 6. So I'm going to plot those first thing on my grid. So I do have those. There's my x, there's my y, and we have 2 and 3, 4, 5, and 6. So our x-intercepts are the coordinate points 2, 0, and 6, 0. Recall the line of symmetry is right in the middle, so the line of symmetry here should be at the coordinate point, or the line x equals 4, which would be right in the middle, as we can see visually, between my x-intercepts. So this should be x equals 4. Then to find our vertex, recall that we would plug in our 4 into our original equation, which I will do over here. So our vertex would be 2 times 4 minus 2 times the quantity 4 minus 6. So y equals 2 times 2 times -2. 2 times 2 is 4. 4 times 2 is -8. So our vertex should be at the point 4, -8. Now let's see if I graphed enough coordinate points there. So 4, -1, 2, 3, 4, 5, 6, 7, 8, and just perfectly there. And the last part of this is to find the y-intercept. So recall we're going to plug in a 0 wherever we see an x, because when we cross the y-axis, x is always 0. So I'm going to get 2 times -2 times -6. 2 times -2 is -4, and -4 times -6 is 24. So my y-intercept is 0, 24. Notice the difference in number 2 with number 1. There is a number listed in front of my linear factors, whereas in number 1, the number that was listed was 1, so we don't need to write it there. In number 2, our number listed as 2. This number that's located in front of your linear factors will help tell us what the vertical stretch is. So part of this lesson was discovering what the vertical stretch is. Keep in mind from a previous lesson, we can figure out the vertical stretch by using the rule over 1 up to A to get the next point, or over 2 up 4A. So what I'm going to do is I'm going to count over from my vertex how many it would take for me to get to the x value of my next x-intercept. So I went over 2. So that means I have to go up 4 times a. So to find the a value, which is this value in front, I'm going to have to count up from here, and I get 1, 2, 3, 4, 5, 6, 7, 8 coordinate units. So that means 4a is equal to 8. Divide that by 4, and a is 2. That is why there is a 2 written in front. So anytime you're given the equation, you can also graph the parabola by going over 2, up 4 times 2, or up 8. So now let's just sketch this graph. I didn't graph the 0, 24 because it was off my grid, but we do know that if we had enough room, we'd be graphing that as well. Keep in mind, because my a value here is positive, that's why I'm facing up. So we did investigate another example, and then we summarized. So in number 4, we were asked, based on the examples, how can you use a quadratic function in factored form to a, find the line of symmetry of the parabola? Well, the line of symmetry is a line that runs through the midpoints of the x-intercepts. And we can see that in the previous 2 examples, that if we know the x-intercepts from our factored form, we can find the number right in the middle of those 2, or the midpoint, and that would be our line of symmetry. To find the vertex, we would substitute the x value of the axis of symmetry into the equation. To find the x-intercepts of the parabola, we would set each factor equal to 0 and solve for x. To find the y-intercept of the parabola, we would substitute 0 for x in the equation and solve the equation for y. And finally, to find the vertical stretch of the parabola will be the constant factor that's written in front of the linear factors. So for example, if I give you the function f of x equals 3 times the quantity x plus 6 times the quantity x minus 9, the vertical stretch will be 3. The x-intercepts will be -6 and 9, because we would set our factors equal to 0 and solve. In number 5, we were asked to choose any 2 linear functions and write them in the form f of x equals some number m times the quantity x minus c, where m is the slope of the line, and graph the 2 functions. So the 2 that I just picked, which several of you in class picked different examples, was the function f of x equals 2 times the quantity x minus 3, and g of x equals 1 times the quantity x plus 4. So recall from Math 1 how to graph these. I did distribute the 2 to get 2x minus 6, and I'm going to graph that. So we plot the y-intercept first. I'm going to go to -6, and then I'm going to rise to, run to the right 1, rise to, run to the right 1, so that I can graph that line with the slope and the y-intercept. So that line will look like this. And the second line is just the line x plus 4. So y-intercept is 4. And I go up 1 over 1, up 1 over 1, up 1 over 1. And I keep doing that. And let's see if I can, I'm going to also extend that first one just a little bit. And that one was up to over 1, up to over 1. And that one would just extend this way, if it will let me, like so. So eventually you can see that they will intersect. This example actually intersects, it looks like, off my grid. Okay, so then in 6, we're asked on the same graph as 5, graph the function p of x. That is the product of the 2 linear factors you have chosen. So what that means is they're asking us to take this linear function and this linear function or factor, and they're asking us to distribute that. So the first thing we have to do is distribute each of these values in the parentheses, and last distribute the 2. So we would get there x squared plus 4x minus 3x minus 12. We would get, when we combine like terms, plus x minus 12, distribute the 2. So p of x would equal 2x squared plus 2x minus 24. And they ask us to graph this product in this equation on the same graph as above. So what I'm going to do is I'm going to do this in my graphing calculator. So what I've done here in my graphing calculator is I've typed my 2 linear functions that I've talked about in my y1 in my calculator. And I'm going to hit graph so I can see what that looks like. Now the interesting thing was, when I graphed them separately, they were lines. If we go back to the previous page, we can see that when we graphed them each separately, they were lines. But now when they're being multiplied together, we see a different shape. And we know that this shape is called a parabola. In y sub 2, I'm going to type in the equation that we got when we multiplied the 2 linear factors. And the equation that we came up with was 2x squared plus 2x minus 24. If you notice, that red parabola is graphed right on top of the blue, which means that these two are equivalent equations. 2 linear factors being multiplied together will be equivalent to a quadratic function, and the shape of that quadratic function will always be a parabola. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.